Hello everyone, this is Mr. Osama. Today inshallah we are going to talk about chapter 9, lesson 2, algebra readiness for grade 7, which has angle relationships and parallel lines. We need to talk about some vocab or some ideas before starting this session. First of all, we need to understand what is the meaning or what is the definition of the angle. Then we can go through the types of the relationships. So I'm gonna move up a little bit to draw an angle, and we need to write down the definition of the angle. So I'm gonna go up a little bit. First of all, we need to know what is the definition of the angle. What is the angle? What is the angle definition? To understand the meaning of the angle, we need to have a sketch for that. So I'm going to draw an angle here. So here I'm gonna complete my sketch. I have to here to name this A, point B, and point C. To understand the meaning of the angle, we need to go through this sketch here. If I look to the sketch or the graph, which I did it now, I have two rays. The first ray AC, the second ray is AB. The two rays have the same end point, which is A, and the two rays has been united together at the point A, forming what you call the angle. So here the angle can be formed by the union of two rays with the same end point. We can write down the definition of the angle. So angle is the union of two rays with the same end point. In this session, as I said here, I have two rays. I have two rays here. For example, X, Y ray, and another ray starts from X is called XZ. The two rays starts off with the same end point, which is X. This is point here. This is the end point of the two rays, which is. So I'm gonna have X, Y is a ray, and XZ is another ray. Both have the same end point, which is X. So this is X for the vertex of the angle. So the angle formed here, which is highlighted black here, this is angle formed by the union of the XY and the XY and XZ. The union of two rays with the same end point, which is X, formed what we call the angle. The end point of the two rays, it has a specific name. It's called the vertex of the angle. So I'm gonna name this again. Move up a little bit. So here I'm gonna write down the end point. The end point of the two rays is the vertex of the angle. X of the angle. And this is very important. And the ray is called the side of the angle. And the two rays are sides of the angle. We need to have the relationships between the angles, and will be the topic of our lesson today. So the first type we need to talk about is called the vertical angles. The first relationship between the angles is called the vertical angles. We need to have the first relationship. The first relationship is called the vertical angles. If I have two lines, straight lines, intersected at a point M, for example line AB, and the other line is XY. So I have two lines AB, line AB intersected with the line XY at a set of point which is M. I'm gonna name it as M. To the intersection between the two lines at the point M. This is intersection formed four angles. I need to highlight the four angles by different colors, so I'm gonna use the green color. This is angle number 1, angle number 2, angle number 3, angle number 4. If we look at angle number 1 is opposite to angle number 3, and angle number 2 is opposite to angle number 4, and this will form the vertical angle. So angle number 2 with angle number 4 called the vertical angles. Angle number 1 and angle number 3 are called the vertical angles. So what are the properties of the vertical angles? The vertical angles, they are congruent. What does it mean? It means they have the same measure. So I can say the properties of the vertical angles. The properties of the vertical angles. So vertical angles, the vertical angles are, number 1, they are congruent. What does it mean? They have the same measure. So measure of angle 1 equal measure of angle, according to our sketch, we get back 1 is equal to 3, and the measure of angle 2 equal to measure of angle 4, according to our sketch. 2 with 4 and 1 with 3, both, each of them had the same measure. Number 2, they have the same vertex. They have the same vertex. Which is M. And number 3, sides of the vertical angles are opposite rays, and this is very important. Sides of the vertical angles are opposite rays. So we got the definition and the properties of the vertical angles. They are congruent. They have the same vertex, and the other two sides of the vertical angles always be opposite rays. And the main concept here that the vertical angles always are congruent or equals in measure. And this will cover the first definition of the vertical angles. We need to move to the second relation between the angles, which is called the adjacent angles. So we need to move up a little bit. Number two of the relation, which is called the adjacent angle. The adjacent angles. adjacent angles. To draw this, we do have some sketch. I'm gonna do like this. This is straight line, and this is array here. So I'm gonna name it, for example, here A, B, C, D. Angle number 1 and angle number 2. Angle number 1 and angle number 2. What is the criteria of the adjacent angle? The adjacent angle has a specific criteria that they have the same vertex in this figure, which is B, and they have a common side, which is the ray BD. So the adjacent angles have the criteria or has some properties which is called they have the same vertex and they have a common side. The common side here is BD. So if we look to the figure right now, angle 1 and angle 2 said to be adjacent angles. Why? Because they have the same vertex B and they have BD as a common side. So I have two angles here, CBD and ABD, which is angle 1 and angle 2. Both of them are adjacent to each other. Why? Because they have the condition for being adjacent, which is common vertex, which is B, and common side, which is BD. So I can say that angle 1 and angle 2 are adjacent angles. Why? Because they have number 1, same vertex. Number 2, they have a common side. They have a common side and same vertex, and this will cover the definition of the adjacent angles. Somebody will ask, that the adjacent angles are congruent? It's a special case. Maybe yes, maybe not. It depends on the criteria or the condition of the given example. If the question asks you, give you some information that the relation between the two angles are equals in measure, they have the same measure or not, it depends on the kinematical condition of the figure. So sometimes it works to be they are adjacent. The adjacent can be equals or not. It depends on the given information. It's not congruent all the time. It's not congruent all the time. It depends on the given information. And this will complete the definition of the adjacent angles. We need to move to the third relationships between the angles, which is called the complementary angles. Complementary angles. We need to move up a little bit. What is the definition of the complementary angles? If the sum of any two angles equals 90 degrees, the two angles are said to be complementary angles. We need to write down the definition of the complementary. This will be number 3. Complementary angles. The definition of the complementary angles means if the sum of two angles, if the sum of two angles, if the sum of any two angles equals 90 degrees, the angle is said to be complementary angles. Said to be complementary angles. We need to have a sketch for that. So if, for example, if I have two angles, this is x, y, z, and this is L, for example, angle number 1 and angle number 2. If the question said that measure of angle LXY equals 90 degrees, that means it's right angle, and this is angle made up of two angles, which is angle 1 and angle 2. That means measure of angle 1 plus measure of angle 2, it will be 90 degrees. Then the conclusion would be angle 1 and angle 2 are complementary. Complementary angles. So here the definition of the complementary angles: if the sum of two angles equals 90 degrees, then the two angles said to be complementary angles, and this will be the third relationship between the two angles. We need to move to the fourth relationship, which is called the supplementary angles. Number four, which is supplementary angles. Supplementary angles, the sum of any two angles equals 180, it will be supplementary angle. So the sum here equals 90 degrees. Say I have straight line and I have a ray intersected with. So here I'm gonna say this is angle number 1 and this is angle number 2. Measure of angle 1 plus measure of angle 2 equals straight angle, which is 180 degrees. Then the conclusion will say that angle 1 and angle 2 are supplementary angles. Supplementary angles. So the definition of the supplementary angles is the sum of any two angles equals 180. So supplementary angles, the sum of any two angles equals 180 degrees. It will be the supplementary angles definition. So right now we got four relationships. Number 1, the vertical angles. Number 2, the adjacent angles. Number 3, the complementary angles. Number 4, the supplementary angles. We need to cover another thing. Shows a lot of relationships between angles. If we have two parallel lines and there is one line intersected with the two lines, which is called the transverse. So we need to have some new vocabs. It will help us. So I'm gonna move up a little bit. If we have two parallel lines, L1 and L2, and there is one line, it's called transversal, which is intersecting the two lines, which is L3. I have two parallel lines, which is L1 and L2. So L1 parallel to L2, and L3 is called transversal. Transversal means intersecting the two parallel lines. This is transversal L3, forming a lot of angles: angle number 1, angle number 2, angle number 3, angle number 4, angle number 5, angle number 6, angle number 7, angle number 8. So once we find that a parallel lines has intersected by another line, which is called transversal. This is transversal, forming some specific types of angles. We had adjacent, we had vertical angles, we had complementary, we had supplementary. So we need to add some extra types or extra relationships between angles. For example, here angle number 1 and angle number 6. Angle number 1 and angle number 6 said to be corresponding angles. said to be corresponding angles. So the fifth relationship, which is called the corresponding angles. So number 5, we need to talk about number 5, the corresponding angles. The corresponding angles, they are always congruent. So here the corresponding angles, as I showed before, is 1 and 6. They are lie on the same side of the transversal. So I'm gonna make it here in a clear. This is angle number 1 and this is angle number 2. Angle 1 and angle 2, they are corresponding angles. Angle 1 and angle 2 are corresponding angles. They are on the same side of the transversal. So they are on the same side of the transversal in corresponding positions, and they always, angle 1 always congruent to angle 2 because they are corresponding. So corresponding angles always are equals in measure. Corresponding angles are always equals in measure. So right now we got the fifth relationship, what's called the corresponding angles, as I said before. So I'm going to get back a little bit here. Angle number 1, angle number 2, here they have the same, they are lie on the same side of the transversal. They have the same measure. So measure of angle 1 always equal measure of angle 2 because they are corresponding angles. This will cover the fifth relationship between the angles. We need to move to the number 6, which is called, so number 6 is going to be alternate interior. It's called alternate interior angles. We need to identify the sketch of the alternate interior angle. Say that we have the two lines, parallel lines here, and this is the transversal. Angle number 1 and 2, 3 and 4. So angle 1 with angle 2 alternate interior angles. Angle 3 and angle 4 alternate interior angles. So these two pairs are an example for the alternate interior angles. So the alternate interior angles, they are on the corners inside the transversal. So what is the relation between the alternate interior angles? They always are congruent, or they are equals in measure all the time. So we can say that measure of angle 1 equal measure of angle 2, and measure of angle 3 equal to measure of angle 4. Why? Because they are alternate interior angles. They are alternate interior angles. So this will cover the definition of the 6 types which we had, or the 6 relationships between the angles. We had at the beginning of the session the vertical angles, then the adjacent angle, then the complementary angle, then the supplementary angles. Then we move to the corresponding angles. Then we move to the final type or relationship, which is called the alternate interior angles. All these relationships will help us to solve a lot of exercises in the next session. By this is the sixth type of the or six relationships which we have right now. I think we covered all relationships between the angles, and I hope you guys get understand what we've been through. Thank you for watching this video. Inshallah, I'm gonna meet you again for another video for some exercises according to this session. Thank you for watching the video. Have a good day and goodbye.